let's look at some of the quiz problems that seem to be an issue for week 2. So here's one. If sine theta is minus 4 over 7 and theta is in quadrant 4, then find the rest of the trig functions. So I like to draw a diagram because that's, I think in pictures rather than in symbols usually, if I can. So since sine is negative 4 over 7, right? Sine is the y-coordinate over the hypotenuse. And the hypotenuse can't be negative. So this minus sign, it has to go with the y-coordinate. So y is negative 4, and the hypotenuse, which is also the radius of the circle, is 7. So now we can, and we're in quadrant 4. So we're down here somewhere. The y-coordinate is minus 4, and the hypotenuse is 7. Now that we know two sides of this right triangle, we can use the Pythagorean theorem to get the other side. So let's see, I guess the square root of 7 squared is 49, minus 4 squared is 16. So this is going to give us square root of 33. So, and I should have a plus or minus here, but we're in the fourth quadrant, and in the fourth quadrant, horizontal coordinates are positive, so we're going to choose the positive one here. And now we can write down all of these trig ratios just using this right triangle. So cosine is adjacent over hypotenuse, so that's negative root 33 over 7. Tangent is y over x, so minus 4 over root 33. I'm sorry, I have a minus sign here, but that should be positive. Secant is just the reciprocal of cosine, so 7 over root 33. Cosecant is the reciprocal of sine, so that's minus root 33 over 4. And cotangent is the reciprocal of tangent, so minus root 33 over 4. Oh, I misread something. This one, reciprocal of sine. Sine is up here. I just looked at the wrong line. Reciprocal of sine is minus 4 over 7. All right, so careful about what quadrant you're in. All right, number 4, simplify secant times cosine into a single trig function. Well, not every product of trig functions can be simplified into a single trig function, but this particular product can. So if we try to simplify this, how could we start? Well, if this simplifies, there must be some relationship between secant and cosine, and hopefully that's enough to make you think, oh wait, secant is the reciprocal of cosine. So this is 1 over cosine t times cosine t. But now hopefully you see how it simplifies, right? We can simplify our fractions, and this just gives us 1. So this whole thing is 1. In number 6, so finding the coordinates of a point on a circle with radius 30 corresponding to an angle of 20. So one thing to notice is that this 20-degree angle is not a nice angle. It's not one of the, it's not 30, 45, 60, 90, or anything like that. So we're going to have to get a decimal approximation. Right now we don't have any tools to get values for trig functions unless it's one of the nice angles. So 20 degrees is about like this. And the radius of this circle is 30, so here's our 20 degrees. And remember, when you have an angle in standard position in a circle like this, the coordinates of this point are always r cosine theta, comma, r sine theta. People have a tendency to forget to multiply by the radius, so, don't forget that, I guess. So now we can just put everything into, put all our information into this formula. So radius is 30 times cosine of 20 degrees. And then the y-coordinate is 30 times sine of 20 degrees. And now it's calculator time. Right? We can just dump this all into a calculator. Make sure I'm in degree mode. I'm in radian mode at the moment. There we go, degree mode. So 30 times cosine of 20. And I get 28.19191, right? We have to be careful about rounding because the problem is being a little picky about how we round. And then for y-coordinate, 30 times sine of 20 degrees, I get 10.261. Okay. And you know, this seems about right because with a 20-degree angle, the x-coordinate should be bigger than the y-coordinate, and that's what we're seeing here. So this seems plausible. All right, number 8, a function whose graph looks like this. Okay, so if I'm thinking about getting a formula for a trig graph like this, the first thing I look at is where's the min and the max, right? So the minimum here is here, so that's at -3, and the max is up at 7. And once I have a handle on the min and the max, then I can find the midpoint. So it looks like the midpoint is at 2, right? 2 is halfway between -3 and 7, so the midpoint is here at 2. Okay, and now that I know the midpoint, I notice that the graph starts at the midpoint and starts going up. And that means we're going to use a sign with a positive value for a. Right? Because positive sign starts in the middle going up. So we're going to have a positive value for sine like this. Since the midpoint is 2, that means we're going to have to do a vertical shift of 2. And also, since the distance from the top down to the midpoint is 5, that means we need a 5 out in front like this. Okay. There's no horizontal shift because we're starting at the middle, just like sine does. So now we just need to figure out what is this value k here, which I usually call this omega. Our book has been calling it b, but you know, it doesn't really matter what you call it. Omega is or k, I guess. I should use the notation that the problem is using. Since we're using sine, the numerator in this formula is the period for sine, which is 2 pi, divided by the period for our graph. And our graph, let's see, the period, one cycle starts here, which is, I guess, -10.5, which that's a clumsy number, and it goes up to here, which is 3.5. So altogether, that's 14, I guess. So this is pi over 7. So now k is pi over 7, so we can put that in here. Pi over 7 times x. And we're done. All right, last one to look at is number 9. Ferris wheel is 10 meters in diameter, so you know, stop right there. Usually we need radius, so the radius is 5 meters. And it's boarded from a platform 5 meters above the ground. Okay, so I guess maybe we should draw a picture here. So we're boarding 5 meters above the ground, and the radius here is 5 meters. That's either a tall platform or a small Ferris wheel. Okay, 6 o'clock position on the Ferris wheel is level with the loading platform. Wheel completes 1 full revolution every 2 minutes. So this is rotating at 1 revolution per 2 minutes. So that's 1/2 a revolution per minute. And we need to write a function that gives the height in meters after t minutes. Okay, so if we're starting at the bottom, right, as this goes around, the height is going to start at the bottom and then go up to the top and then back down to the bottom and then repeat. So we're starting at the bottom of a cycle, and that means we should use a minus cosine. Right? Sine starts at the middle of a cycle, cosine starts at the top of a cycle, negative sine starts at the bottom of a negative cosine starts at the bottom of a cycle. So we'll use minus cosine. The distance from the center to the top is the same thing as the radius of the circle, so that's 5. So that's our amplitude, 5. The center of our motion is at height 10, so we need to shift this up 10. And now we just need to figure out what is the angular speed. Right? Usually what goes in here is the angular speed times time. And we know the angular speed. It's 1/2 a revolution per minute. But to use cosine, we have to have omega in radians per minute. So we need to convert this to radians per minute. And there's 2 pi radians in 1 revolution. So this is pi radians per minute. All right, so now we can put that in here. We get pi times t. And we're done.